Here we're going to establish another trigonometric identity. We want to show that tangent theta plus cotangent theta is equal to 2 times the cosecant of 2 theta. We can start with either side. We're going to go ahead and start with the left-hand side. We'll have tangent theta plus cotangent theta. And the first thing we want to do is rewrite these using sines and cosines. So tangent theta we're going to write as the sine of theta over cosine of theta. And then cotangent we're going to write as cosine of theta over the sine of theta. We'd like to get a common denominator, so our common denominator will be the product of cosine theta and sine theta. To do that, we're going to multiply this fraction, the top and bottom here, by sine theta. That will give us sine squared theta over sine theta cosine theta. Plus, we want to multiply this fraction, the top and bottom, by cosine theta. That will give us cosine squared theta over sine theta cosine theta. Since we have our common denominator, we can combine these two fractions. That will give us sine squared theta plus cosine squared theta over sine theta cosine theta. Recall that sine squared theta plus cosine squared theta is 1. So this is 1 over sine theta cosine theta. See that our right-hand side has a factor of 2 in there. We don't have that yet. We're going to go ahead and multiply the top and bottom of this fraction by 2 so that we can get that 2. This will give us 2 over 2 sine theta cosine theta. Now if we look at this denominator, the 2 sine theta cosine theta, that's another identity. That's equal to the sine of 2 theta, using our double angle formula. So this gives us 2 over the sine of 2 theta. Since sine we can rewrite as 1 over the cosecant, we'll have 2 divided by 1 over cosecant 2 theta. I'll bring the cosecant up into the numerator, and we'll get 2 cosecant of 2 theta, which is our right-hand side.